Hello, and this time we're looking at parametric equations and a couple of examples where there's, I say an applied situation, but something more than just here's the equation, work it out, where we're trying to use the parametric equation skills that we've looked at in order to solve this possibly slightly contextual question. So let's have a look. A particle is moving in the xy plane such that its position after time t seconds relative to a fixed origin is given by the parametric equations. Excuse me, and they've given us a nice little curve. So you can imagine, I don't know what, how time features into this, but maybe it starts up here and it sort of swings around, and that's its actual, if you're looking down on the table, that's the shape of the motion that you would see. We've got the parametrics here, fair enough. The diagram shows the path, yes, saw that. Find the distance from the origin to the particle at time t. Okay, well, if we want the distance from the origin to any point, then let's say it was this point, then the distance from the origin to that point we can get with Pythagoras. If you imagine that being a right angle triangle, but my drawing is terrible, so you have to use your imagination. Then if we know the x-coordinate and we know the y-coordinate, then we can just do the Pythagoras on those two values and we'll get the distance from the origin to that point. So the real question for part A is what are x and y values at t equals 0.5? But we have equations, so we can just work it out. So x is going to be 0.25, that's 0.5 squared, minus 3 lots of that, so minus 1.5, plus 2, all over 0.5. Now I could work that out, but I'm going to put it on the calculator. In fact, what I'm going to do is I'm going to put in 0.5, and I'm going to store it as a, and then I can just type it in with a, and I don't need to worry about even getting the substitution right. So alpha a squared, let's do fraction first. Alpha a squared minus 3 alpha a plus 2 all over alpha a, and this gives me an x value of 3 over 2. And the y value is just 2 lots of it. Well, I think I can do that without substituting it in. I was expecting that to be also grotty, which is why I substituted in, stored the a, so I could substitute there and do it again. But I think I can manage 2 times 0.5 is 1. So we've got, I don't know why it says divide there, we've got our two coordinates here, our x and y coordinates, for this point when time equals 0.5, so up here somewhere, wherever it is. These are our coordinates. And we can find that distance, like I said, by doing Pythagoras. So the square root of 3 over 2 squared plus 1 squared, square rooted. So calculator again, and that's going to be, pressed it twice, square root of 1.5 squared plus 1, all square rooted, and we get the answer of root 13 over 2. Now, if it actually wanted it, you could obviously do it as decimal. It doesn't specify what it wants, but if it hopefully an exam would, and you'd know if you wanted it exact or if you want it decimal. If in doubt, write both down, and then you won't lose a mark. Well, anyway, you'd hope. Then it says, find the coordinates of the points where the particle crosses the y-axis. Okay, well, we've got 2 points here that we can see, one there, one there. And we know something about this. We know that when it crosses the y-axis, then the x value is going to be 0. So we can kind of work that back. We can say, okay, if this is 0, then can we process this? Yes, we can. Of course we can. So put 0 in here for x, and we need to know what value of t will give us the value. What value of t will give us x equals 0. So we've got that this equals t squared minus 3t plus 2 all over t. Well, let's rearrange that. If we times up by t, well, actually, that's just going to be 0 times t. So in this situation, we can actually get rid of that, and we can just solve this for t as a quadratic, which I believe will factorize t minus 2 and t minus 1. 1 times 2 is 2, and take them away for 3. Yeah, perfect. So we've got the t values of 1 and 2 for our points of intersection, but we don't want the t values. we want to find the coordinates of the points where they cross. So the y values, well, this is nice and easy because it's just doubling. So we're going to have that this is the coordinate 0 and double the t value is 0, 4. And this one is going to be 0 and double that, it's 0, 2. Those are our two coordinates where it crosses the y-axis. Another particle travels in the same plane with its path given by this equation. Show that the paths of these two particles never intersect. Okay, so they don't intersect. Well, if they did intersect, what we would do is we would substitute the t values, the functions of t for x and y into this, and then we'd solve for it. And we'd get the value of t that works, and we'd work back. So if we do that, we should find that we can't get a value of t. So let's have a look and see what happens. So substituting these in, we get 2t equals 2 lots of all of this gubbins. So crumbs, t squared minus 3t plus 2 all over t, and then plus 10. Right, okay, so if we times everything by t, then I think we're going to have to delete this and move up the page a bit. So times everything by t. So we're going to have on the outside 2t squared equals, and then times through by the 2 here, 2t squared minus 6t plus 2 times 2 is 4, and then plus 10t. And now we can just rearrange all this and get it into a quadratic. So 0 on one side, we've got that 2t squared on one side, and we've got 2t squared on this side. So those are going to go, and we end up with 4t, as in 4, then the letter t, not 40, because we've got minus 6t here, and then we've introduced the plus 10t, and then plus 4. And this will give us that t equals, so move this across, is minus 4 over 4, so t equals minus 1. Now, before you start thinking, uh-oh, something's gone wrong, I thought you said that we shouldn't be able to get a t value. Okay, well, we have got a t value, but look at the definition. T has to be greater than 0, and the only place that this will actually intersect is when t equals minus 1, and we're saying that doesn't exist. Okay, it's like saying, I'm not saying that t is time in this situation. It might be, but I'm not saying it is. But let's say that we're looking at throwing something, and it's going to be a parabola, or approximates as a parabola when we throw it. So here I am on a cliff, and I throw the ball, and then it hits the ground at time t equals 12 seconds. Well, the maths would also say that it's at the same height of the ground at t equals minus, I don't know, make it up, minus 8 seconds. We know that that can't happen because, it's not behaving like a projectile until I project it, so we can't go into minus time, and even if it could, it would have to go through solid cliff to get to that level. So we know that it doesn't exist in that sense, and it's the same thing here. We know that this doesn't work because it's trying to be minus for the maths, and we're saying, no, it can't be minus, it has to be greater than 0. So we have shown that they never intersect. We probably should put some words on this in exam. You would get to this point and you'd say, okay, they would intersect when t equals minus 1. T is not allowed to be minus 1, it has to be greater than 0, therefore they don't intersect. Boom, move on. Indeed, let's move on to my second example. We've got the profile of a hill climb in a bike race, and it's modelled by the following parametric equations. So we've got, I presume these m's here are meters rather than a variable. If they were a variable, then they'd probably be italic. See how the x, the t, and the y are in italic, but the m isn't. So I'm pretty sure that that's meters for the height and distance, the horizontal distance of this hill, this climb that we're doing. And so let's read the question. We've got these parametrics. Find the value of t at the highest point of the hill climb. So that's this point here. Okay, so the highest point here is going to happen when y is at a maximum. So if you just think about how sine works, whatever t is, yeah, and then times by 2, doesn't matter. When you do sine of something, the biggest value you can get from sine is 1, and it happens there. Okay, 1. So the biggest value that can be is 20 times 1. So the value of t at the highest point of the hill climb, okay, well, I didn't need to work out 20, so the highest point there is 20. I'm going to write that down just in case we need it later. But the highest point is going to happen when sine of 2t equals 1. And so now we can work this out. We can say, okay, so inverse sine of 1 is going to happen. We're in radians. So just got to think in radians. So let's have my picture of sine again. Okay, at 1, it's going to happen at pi over 2. So that's okay because we're allowed to be pi over 2. So 2t, oh wait, no, actually, forget that. That's going to happen for this sine. Yes, sine of 1 happens at pi over 2. So 2t is pi over 2. So actually, we don't need to go up there anyway, because when we divide that by 2, we get that t is happening at pi over 4. This maximum, is happening at t is pi over 4. Do we need to do a cast diagram? No, I don't believe we do, because it's 1, we're only going to have that maximum once in this. We're not going to have it twice, and so the next one is going to happen, after 2 pi radians, and that's not going to then fit into our range, so we don't need to do the cast diagram. Okay, so we've got the t value. We did get the y value as well, but we didn't need it. We've got the t value. Hence, find the coordinates of the highest point. Well, I'm glad I wrote that down, having sort of thought about it and worked it out. So we know that's 20, great. We can now work out the x value, because we know the t value that corresponds. We're just going to put that in. 50 tan of pi over 4. Okay, reach for the calculator, check that we're in radians. Yes, indeed we are. And we're going to do 50 tan of shift pi over 4, and we get the answer of, 50. Well, that makes sense. I didn't need to do that, did I? Because tan of pi over 4 is the same as 45 degrees, so that would have given tan as 1, so of course it was going to be 50. So that was a bit silly, but it doesn't hurt to check these things on the calculator. So the coordinates of the highest point is 50, 20. So there we go. Find the coordinates when t equals 1 and show that at this point a cyclist will be descending. Right, okay. Let's clear a bit of space. First of all, find the coordinates when t equals 1. Well, that's easy. We're just going to substitute it in. So we're going to work out that x equals 50 tan 1 and y equals 20 sine 2, because it's 2 times 1. So let's just work out what those are. 50 tan of 1 in radians, of course, is 77 wrong button, that one, 0.87. And the y value is going to be 20 sine 2, which is 18.19. Okay, so here are the coordinates. Well, we should write it as a coordinate, 77.87, 18.19, and show that this is a point that at this point the cyclist will be descending. Well, we can actually get this from the graph. We know that the maximum is at 50, and after that, because it's a maximum, he must be coming down from that maximum, and because we're at 77 is greater than 50, therefore we are on this descending point on this graph. We're coming down. Those are my 2 examples. If you have any questions about those or other modelling questions using parametric equations, then you can pop questions into the comments. But otherwise, I'll say cheerio for now.